Hey guys, I'm sorry I'm not with you again today, but we're going to make the best of it that we can. We're going to carry forward that information that we talked about earlier in the week. We are going to work on some more static simulations. We will be applying some fixtures, some fixed geometry restraints, and we will also be applying some forces to some parts and running those analysis and applying different materials to see how that affects the stresses that are behaving within the part. So hopefully you can walk through this video, and I'll walk you through one of the exercises, and then I'll leave the rest for you to do the similar exercises and steps for the other parts and find the information that I'm looking for. So you should have a handout that has 3 pages on it. We want to make sure that you leave that with Ms. Banks along with signing in the sign-in sheet. And before you go home today, make sure you leave this assignment with her with your answers put together. You're also going to generate a report that you print out and attach to these 3 sheets. So I want you to staple it all together. There should be a stapler there near the printer, and staple everything together before you leave it with Miss Banks today. There's no additional homework for tonight, so that's some good news for you. So go home, enjoy your evening, and come back on Friday and we'll do another similar video lecture like this. So stop and start the video as many times as you need to make sure that you're successful with the projects. Thanks. Launch SOLIDWORKS and browse the first year Upward Bound folder and open the Lab 2_1 model. Start a new static simulation. If the simulation tool isn't available, turn the add-in on. Apply a fixed geometry fixture to the rear face of the part. Apply a 35-pound force to the edge on the opposite end of the part. Make sure the vector is directed down. I used the vertical line to direct the arrow, and then I had to reverse the direction. Set the units to English pounds and the magnitude to 100 and pick the green check mark to finish the tool. Pick the Run This Study tool and wait for the analysis to finish. If you get the excessive displacements warning, just pick Yes to continue. The stress, displacement, and strain results should appear. Always double check your units to make sure they're set correctly. In this case, I need to switch the units. To do this, right-click on the chart and pick Edit Definition and change the units to PSI. Repeat the process to correct the units for the other results as well. I guess you've noticed I've blurred out the answers you needed to add to your worksheet, but you should see them on your screen now. I'm going to right-click on my Static 1 tab and pick Duplicate to copy the study. Next, I'll change the material to AISI 1020 and rerun the study. Pick the Run tool and wait for the analysis to run. Pay attention to which material you're recording your answers for on your sheet. I believe I ran this in the reverse order, but just record the answers in their proper locations. Next, I'll ask SOLIDWORKS to prepare a nice report for me. Pick the Report tool from the Command Manager. You don't have to do this with the first two parts. Turn off most of the sections as we only need a few of the parts. You need loads and fixtures and study results for sure. Add your name as the designer and publish the report. Save it directly to your desktop. Wait for the report to generate. You will generate a report only for Model 3. Review the report. Print your report to the HP 5200 printer, which is in the front of the class. Good luck. Start, stop, and pause and rewatch the video until you get it right. Be sure to sign in. Leave your worksheets with your printed report stapled together with Ms. Banks. Come back Friday for another similar problem. Thanks.